earlier videos, we've looked at feature selection with the caret package. In this video, we cover two techniques for feature engineering, which is designing new features from existing data. The first technique is PCA, Principal Components Analysis. This is a data reduction technique to reduce the number of predictor columns and deal with the cursive dimensionality we've talked about before. PCA transformed the data into a new coordinate space while reducing the number of axes. Each axis of the reduced space represents a principal component. The first principal component represents the dimension of greatest variance, and other PCs represent decreasing variance. An intuitive explanation is to visualize n-dimensional space reduced to a k-dimensional elliptical space where k is smaller than n. In data reduction techniques, we are losing data and information and may correspondingly lose accuracy in models we build. We're going to run PCA on the iris data, and we see that after running this, it needed two components to capture 95% of the variance. What we see in the plot is now that we're plotting the iris data on the two principal components, PC1 on the x-axis and PC2 on the y-axis. And we see that one class will be fairly easy to separate, the other one not so much. This looks a little cloudier than the original iris data. Let's run K and N on that, and we see that our accuracy is 86, which is lower than if we used the original predictors. On the decision tree, we got a 90% accuracy. Next, we look at LDA, linear discriminant analysis. PCA was an unsupervised technique, but LDA does consider the class. LDA seeks to find a linear combination of the predictors that maximizes the separation of the classes while minimizing the within-class standard deviation. There is an LDA function in package mass, which we'll use on the same iris data. We see that the LDA analysis has identified means for all variables by class. Let's use the LDA model for prediction. We got an accuracy of 1. When we plot the LDA predictions by class using two linear discriminants returned by the model, we do see a nice separation. The color of the points indicates the true class, while the shape indicates the predicted class. In this case, we had 100% accuracy. In comparing PCA and LDA, the most significant difference is that PCA is unsupervised and LDA is supervised. Both can be used for dimensionality reduction. Both reduce the 4 iris predictors to 2 predictors. LDA will have an advantage over PCA when the class is known.